Welcome friends. Today we are going to solve three problems in control system. This is the first problem. In this first problem they have asked to find the transfer function TD of S. If you see in this block diagram there are two input signals D of S as well as R of S, where C of S is the output of this block diagram. So if we have to find the transfer function between C of S and D of S, we should make the remaining inputs to 0. So by making this R of S to 0, we can easily simplify this block diagram and can be drawn as follows. Here here I am going to I am making R of S to 0 and simplify this block diagram. C of S is the output and I am taking a feedback signal, and H of S here becomes 17. These two blocks will be in cascade connection. So any two blocks in cascade connection can be multiplied and replaced by a single block with a gain of 17 by 5 here. So anything of this format, or consider this one a negative feedback control system where output Y of S and input as X of S can be replaced. This block diagram can be replaced by a formula G of S by 1 plus G of S into H of S. So this is the transfer function for the block diagram of this form. So in our problem, this block diagram looks similar to this block diagram. So we can find the TD of S, that is transfer function due to the signal D of S, as C of S by D of S, where C of the simplified formula is G of S by 1 plus G of S H of S. In our case, G of S is 1 by S into 4S plus 1 and H of S is 17 by 5. So replacing the concerned thing, you will get 4S plus 1 into 17 by 5. If you simplify this, you will get the answer you will get the answer 17 sorry 70 17 by 20 S square plus 5S plus 5. I'm sorry. On, on simplifying this, you will get the answer 5 by 20 S square plus 5S plus 17. So the answer for this one is C1. So coming to the second problem here, that we have to find the transfer function for this following block diagram. This is before we going to crack this one, you should be aware of the reduction techniques used in this block diagram. So here they have moved by moving the branch point ahead of the block, we can easily simplify this block diagram. So I'm going to simplify this block diagram. RFS, this is solution for second question. I can make this so this is the given block diagram. This is the given block diagram. I'm going to simplify this one. So RFS, I'm going to move the branch point from P to Q. So even if we move the branch point, the input and output and also the branch signals must not be affected. So for that, I'm going to divide by G. Just have a look. So when I'm moving the H1 block from P to Q, it will become H1 by G because I'm going to divide. If I take the signal from here, the H1, the signal to this will be multiplied by G, that is G into H1. Since I am going to move this branch point ahead of G, I'm going to divide it by G. So this is one of the reduction techniques. If you have any doubt, you can go and refer the reduction techniques so that you can have a better idea. So the output signal is C of S. So the simplified diagram becomes like this. G by 1 plus G H2, and also these two are, this is a branch with a unity gain and this is branch with a gain H1G. These two are in parallel connection, so I am going to add H1 by G plus 1 or 1 plus H1 by G. So further simplification, RFS G by G plus H1 by 1 plus G H2. So after simplification, you would be getting this block diagram with the transfer function G plus H1 by 1 plus G H2. So the answer is D1. Coming to the third question, Here the block diagram is shown. We have to simplify and find the transfer function C by R3. So for this, we'll simplify this diagram. So here, if you consider this block diagram, here there are three input signals, R1, R2, R3, and one output signals, that is C. So we have to find the transfer function between output C and the input R3. This one, input R3 and output C. So we are going to make R2, R1, R2 has 0. So by making R1 and R2 0, this simplified block diagram can be written as R3. This is solution for the third problem. Third question. So R3 sent to summation, and 0.752 and 0.3. This block and this block and this block are all come in cascade connection. 0.75, 0.75 and 2 and 3 all will come in cascade connection by making R1 and R2 as 0. And 1 by 4 can be written as 0.25. This is H of S, and this is of the form positive feedback control system. Since if you look at this summation here, plus symbol is there. So those in cascade connections can be multiplied. So the transfer function can be written as C by R3, which is nothing but G of S by 1 minus G of S H of S. Here, or simply G by 1 minus GH. Here G is 0.75 multiplied by 2 multiplied by 3, and H is 0.25. So the transfer function is 0.75 multiplied by 2 into 3 divided by 1 minus G is 0.75 into 2 into 3 into 0.25. So by solving this in calculator, I advise everyone to use the virtual calculator whenever you are solving the problem. So 0.75 into 2 into 3 becomes 4.5 by 1 minus 1.125. So which is 4.5 by 0.125. So 4.5 divided by 0.125 will yield 36. So the answer is 36. So this is the solution for this third one. Thank you.